So in this section, we are going to continue working with logarithmic and exponential equations, particularly logarithmic equations. These are obviously equations where the unknown that you're solving for is embedded as part of a logarithm. And the way to do this, in addition to just remembering the way you can rewrite everything has a logarithmic form and an exponential form. But the main idea here, the basic strategy, is to put a logarithmic equation in one of these two forms. Obviously, if you can put it in this form, you want to, because then you can just drop the log base a and set f of x equal to g of x. Sometimes you can't do that, but if you can write this as a single logarithm equaling another expression, you can just write this in exponential form. You could write the exponential form of this equation would be a raised to the g of x equals f of x. And maybe that, so you get something like this. And that may or may not be something that would be easier to solve. So we're going to look at just a bunch of examples. The best way to learn this is just to learn by example. Start with the easier ones first. Here you have the common log of x plus 6 equals 1. The way it's already in this form where a is 10. So if we rewrite this in exponential form, because the 10 is implied here. So this says the 1 is what you raise 10 to get x plus 6. So we get that 10 to the first power is equal to x plus 6. And then you can see that that x has to be 4. Okay. Now you always want to check your answer, because sometimes a solution to this equation might not be a solution to this equation, because you can't take the log of a negative number. So we plug 4 back in here and just check that sure enough that the log base 10 of 4 plus 6 is the log base 10 of 10, which is 1. So that works. For example 2, here we can write this as log base 4 of something equals the log base 4 of something else, as long as we deal with this negative 2. And because this is negative 2 times this log, we can bring this negative 2 back up as an exponent. Okay, so now we have x to the minus 2 equals 9, because we have log of something equals log of something else. The bases are the same, so we just drop the logs. We solve this. This is the same thing as 1 over x squared equals 9. So taking the reciprocal of both sides, we get x squared has to be 1/9. And this means that x equals the square root, plus or minus the square root of 1/9, which is plus or minus 1/3. Okay. So it looks like our possible solutions will be 1/3 and negative 1/3. But we can only include one of these, because if we try to plug negative 1/3 in here, we'll have the log base 4 of negative 1/3, and that's undefined. We can't take the log of a negative number. So the answer is going to be 1/3 only. Okay, that's another reason why you want to check your solutions. Okay, because since log base 4 negative 1/3 is undefined. Okay, moving on to example 3, we have a sum of two logs equaling a number. Well, we know how to handle these sum of two logs. This is the log of the product. Okay, and once again, this is a common log, so the 10 is implied here. So we get that 10 squared is equal to x times x minus 21. Okay, this is 100, and this is x squared minus 21x. And distribute the x. And you can see this is going to be a quadratic equation, so we'll put everything on one side. We can subtract 100 from both sides. Okay, and we can use the quadratic formula if we want, or we can see that we're very fortunate this factors nicely as x minus 25 times x plus 4. Okay, and so you get x equals 25 and negative 4. If you use the quadratic formula, where a is 1, b is negative 21, and c is 100, you get the same thing after you simplify. But you can see that this is going to be that negative 4 will not work. Okay, it's only going to be 25 that works, and we can, because log of if you try to plug negative 4 in here, you get something undefined. If you plug 25 in here, you get 25 log of 25 plus the log of 4, and that's what would be the log of 100, which is 2. So x equals 25 is the only solution. So you definitely want to check your answers when you're solving a logarithmic equation.